Alright, in this video we're going to graph a linear function on a coordinate plane and identify key features including the x and y intercepts, zeros, and slopes. Alright, so I have a graph here and I just want to kind of go over some things. Alright, the x-intercept is where our line touches the x-axis, and our y-intercept touches the y-axis. So the y-intercept is right here. That's that right there. That's where it touches. So my y-intercept would be y equals 1, 2, 3, 4. My y-intercept would be 4. If we were to write a point, it's when x is 0, and then it would be 4. So the y-intercept is when x is 0. The x-intercept, that's right here, is when y equals 0. So y equals 0. This one's when x equals 0. Alright, and this one would be 1, 2, 3, 4, 5, 6, 7. So this would be, since it's x, you'd have 7 on the x and 0 for the y. And so that would be it. Or we would say, we would say x equals 7. So those are our x and y intercepts, and that's how you write them. The x-intercepts are also known as zeros. These are other names. Zeros, and you can see why, because they have zeros with them. They're called functions of zero. Zero of function. I've heard zero of a function. So just to give, that's basically what the x-intercept is. It's when our line crosses the x-axis, and it's when we're looking for x-intercept, y is 0. When we're looking for the y-intercept, x is 0. So like if we had a table, let's say we had a table here, x and y, and we had a couple of numbers here. I'll put that there even though it repeats. Okay, and then we'll say, alright, we would want to find our x and y intercept. Remember, the x-intercept is when y equals 0. So I want to circle where y is 0. It's right here. So that right there is my x-intercept. Alright, my y-intercept is when x equals 0. So when I look at that, there's where x equals 0. So my y-intercept, again, this, I'll just draw a little arrow here. That means my y-intercept here would be 4, where my x-intercept would have been 5. That's where I know it crosses the x-axis. So my line would cross, if I was to graph this, 1, 2, well, I want to draw this where it really does look good. Alright, so I'm going to actually draw this so you can see how I'm graphing it. So here's my graph right here. This is my x, this is my y. My x equals 5, so it's 1, 2, 3, 4, 5, so it's right there. And then y is 4, it's positive 1, 2, 3, 4, it's right there. So I would draw a line that would connect those two, or go through them actually, and that would be my line. So that would be how I graph it. Finding the x and y intercept makes it easy to graph a line. Alright, so in this case I went ahead and created an equation in standard form so that way we could find the x and y intercept. Alright, there's a couple of ways you can do it. Remember when you're looking for the, and I like making little tables here, x and y. So remember when we're looking for the x-intercept, y is 0. When we're looking for the y-intercept, x is 0. Alright? So we're going to plug a 0 in for y. We're going to find the x-intercept first. So here we go. We're going to say 3x minus 4, and we're going to make y 0 equals 18. Well, 4 minus 0 is 0, so we have 3x equals 18. Divide both sides by 3, so x equals 6. So my x-intercept is 6. See how that works? Now I'm going to do the same thing, but with y. So I'm going to find the y-intercept. So I'm going to erase this. And I'm going to do the exact same thing looking for the y-intercept. And if I'm looking for the y-intercept, that means x is 0. So I got 3 times 0 minus 4y equals 18. Alright, 3 times 0 is 0, but now I have to bring down my negative because it's with the 4, it's in front of it. So negative 4y equals 18. Divide by negative 4. Alright, negative 4 divided by 4, negative 4 is y. And so I get, and when I reduce this, I get negative 9 halves, which is 4.5. So our y-intercept is really negative 9 halves, or 4.5, negative 4.5. Alright, so how do I graph this? Well, if I was to graph this, here I go. And so hopefully I'll have enough room to do this. This is my x, this is my y. My x-intercept 6, so I'll put a dot where 6 is. 1, 2, 3, 4, 5, 6. So that's right there. The negative 4.5 is 1, 2, 3, 1, 2, 3, 4. So right there. So I'll put my dot right there. And then I would draw my line that would connect the two. And I know it's not going to be perfect, but there it is. How could I find a slope on that guy? If I wanted to find a slope, then I would kind of like use the rise over run and kind of do it that way. I kind of like this intersection. If I drew it right, this intersection here works good for me. So I'd say 1, 2, 3, and then 1, 2, 3, 4, and so my slope could be 3 4.